Let's try again. Cool. So we're back with another one. Let's jump straight into it. So we are mapping the differences array into a new one, square differences, and we're squaring each one of those. Declare sum square differences variable and assign it the value of the reduce. For the callback, return the sum of the accumulator and L. Set the value to 0. How do I define an accumulator though? So again, we've done this before. Okay, so the initial value is like a second argument. Okay, cool. So what we're going to do here is our function. So we take in the accumulator L, and our callback returns C plus L. Accumulator initial value being 0. Not all 0. Cool. So remember that our reduce will take a callback, and we can initialize the accumulator. We'll just match that with 0. With 2 dot map calls and the dot reduce call, you're creating extra arrays and iterating more times than needed. You should move all the logic into the reduce call to save time and memory. Remove the differences, square differences, and some square differences variables and their values. Declare a variance variable and assign it the value of array.reduce for call passing your standard L, but leave the function body empty for now and set this to 0. Okay, so I'm removing differences, square differences, and some square differences. And we're going to sort of chain these together. So we're going to have a callback. Which less than 0. So if I bring the curly brackets there, that will just let me pass it because I've got an empty function. Okay. So we're effectively sort of doing because we're iterating through each element, we're doing the processes that we did before. Instead of creating different arrays, we're doing it for each element, and then we're going to return that into our array reduce. I think reduce then brings it into 1, doesn't it? Yeah, so yeah, cool. Little break. This is like the sponsored ad version segment of the video. Yeah, our sponsor, so they're not sponsored, not officially, but technically kind of, because not for them I wouldn't be able to be doing this. Oh, sorry, I haven't even read what I'm doing. Calculating the variances. Divide the sum of square differences by the count of numbers. So divide your dot reduce call by the length of array. So that's this divided by array dot length time variance. Okay. Once we reduce it, we divide that by the length of the array, number of the array, and that's the variance. Cool. Okay, and now this is the same. So as we've done thus far. Okay, and I'm going to go with a pattern. This might not be the case, and I might be making a mistake of making a presumption, but I think it's a fairly safe bet. Yeah. Standard deviation, the square root of the variance. Okay. Cool. Sorry. Okay, cool. So this is how you use the math power. Okay. Alright, so what they're looking for is a nice little so instead of using the star star to raise it to the power, we can use math power. Take a base and erase it as described by MDN. Quite handy. Okay. That's nice. So there's two different ways of doing it. How does it do that? Does it just take the one value? Yeah. Okay. So instead of that, I can just do that. Square root of variance. And that should do the same thing. Many ways to skin a cat. It's useful if you know a few. Return standard deviation. And I will go and stick it over here. Excuse me. I thought I was muted. Dang it. I'm going to make that presumption again. That it's all good in the hood. There is an ID element, an element with ID standard deviation, so which I can call standard deviation. Cool. Okay, so sort will mutate, so sort is destructive. So that's for a lot of the stuff we've looked at. We'll either create a new array or we'll leave the original array untouched somewhat. Sort doesn't do that. Sort will change the original array that it's called on, which apparently is bad practice. Okay. Okay, so if we slice before we sort, apparently that's useful. Cool. Let's see. Yeah, none of them. That's interesting. So let me give myself a mode of 5. Cool. Okay. So finish that one. Last message from the sponsors, the unofficial sponsors, because FreeCodeCamp is not a sponsor, but it's by virtue of the existence of something like FreeCodeCamp that I'm able to do this. That I'm able to sort of teach myself JavaScript. So we have finished the array methods, and we'll be moving on to functional programming by building a spreadsheet. Oh, this is going to be interesting. Cool. Well, not starting that today. I'll start it tomorrow. But yeah, thank you for tuning in. Hopefully this is useful. I will update the title to just say it was 40 till the end, which was 50. Cool. So today's steps were 40 to 50 for anyone that needs to find that. And we'll start tomorrow. We'll start on functional programming tomorrow. So peace out.